Good morning, everyone, and welcome to today's EnRoute webinar. My name is Bennett. I'll be the moderator for today. Our presenter is Aaron Clapp, Applications Specialist at SAI. He knows everything there is to know about EnRoute, and today we're doing a deep dive into working with meshes in EnRoute. After the presentation, we'll be able to answer any questions you have, either about meshes or any other EnRoute topics. So just go ahead and put those questions in the chat on the side here, and we'll answer as many as we can. Last thing, we are recording the webinar as always, so if you want to review anything that Aaron discusses, we'll be sending you the link to the recording this afternoon, so look out for that in your emails. And that's it from me, so we'll go ahead and turn it over.
All right, sounds good. So today we wanted to kind of round off some of the discussions that we've had about 3D and kind of wrap it up with a nice little bow here in terms of the kind of the last feature that you might be interested in using in EnRoute to kind of create some custom pieces. And so what we wanted to talk about was using the slices and 3D slices and converting files over to a mesh. I know a lot of customers have asked us before, can I send these files to, a 3D printer, or can I do something like that? Or I want to send this 3D texture that I've created and, send it to somebody else to have it either cut or printed or do something with so that they could interact with it. So the first step we want to kind of look at was taking a 3D texture that you've created and converting that over into a mesh so that you can then export that. And then we'll talk about slicing and a few other things like that as well. So the first thing we'll do is we'll go ahead and start with a new blank document, and we'll kind of just start with the real basic process of creating some kind of a texture and then converting that 3D relief, which is kind of unique to EnRoute, and converting that over into a relief or a 3D DXF or a 3D STL file in order to kind of get that to someone else. There are several different formats you can export to. The most common ones I would say in EnRoute are going to be the STL and the OBJ, or the object file. Those are probably the most compatible. They're the ones that seem to be the most commonly used by other 3D applications. So we'll probably stay with that. I know you can get a 3D DXF file or a 3D DXF mesh file as well. You can also import those into EnRoute, but we found that usually the STL is a pretty common format that most applications will use. So let's go ahead and just create a texture here. And let's just pull up something that might be kind of interesting. It doesn't have to be anything crazy, but let's add a texture of 5 inches height here. Oh, this did it in colors. Let's undo that. Do not like the colors particularly. There we go. So we have a 3D object here, or a 3D relief is what we'd call it in EnRoute. So kind of a nice little neat texture, kind of has kind of a little bubble texture there to it. If I want to send this to somebody else, all I need to do is highlight this 3D texture, go to Surfaces, and go to Mesh Tools. So what I can do here is then just go Mesh from Relief. It's going to ask me a little bit about my mesh tolerance. This is all dependent on how much quality you want to add to it. The default is 0.001, which means it's going to be pretty faithful to what you see. The higher you go here, the less kind of quality. And that, again, all depends on kind of what you're doing. We're actually going to see an example. I'm going to show an example here in a minute of a texture that's really, really high resolution, but I'm going to step it down in resolution because what I'm going to do to it next is going to not really matter that much. And so you can save yourself a little bit of effort there. But if it's something where you'd want the accuracy to be good, you can leave it at these default settings. And then if you don't need the quality as much, you can increase these um, and then go with that. So all I have to do then is hit apply, and it's going to process here for a second. Again, this is something that, depending on the size of the object and what quality, what mesh tolerance settings, the edge tolerance setting you chose, how long this will take. This is actually redrawing the entire texture with lines and everything for a 3D part. And so the bigger the piece, obviously, the longer this will take. So sometimes a little bit of patience will be involved here. But this is a fairly quick one. But just kind of know that this may be something that takes a little bit of time. And so just be aware of that since it's having to redraw everything. So it stacks it kind of on top of each other here. So all I need to do then is just click on one of them, which they're both stacked on top of their, so I don't know which one it's actually going to highlight, and then just drag it away. And then at that point, you can move this one out of the way. So now if we look at this in the perspective view, this has now been converted into a 3D object. And you can see how pretty faithful it is to the original file as well. So another thing that you can do to improve the quality of your STL when you convert it over is also improving the quality or the resolution of the 3D STL when you, or the relief when you create it. So one of the things that allows you to do that is when you create your relief initially, you have your resolution down here. For the most part, anything you're doing in EnRoute for cutting, a resolution of 50 will suffice. But if you wanted to, you could go a little higher on this resolution, maybe 270. I probably never would go over 100 just because of how big the files start to get, and you start to create more detail than you can actually use. But if you need a little more detail, you can increase this here, and that will also translate over to your mesh file. You can also, again, change those tolerances up. You could make those tolerances smaller, and you would get a little more accuracy there as well. So that's the basics of just kind of converting something over. Now we can actually take this, and let's just get rid of this guy because we're not going to use it anymore. I'm just going to highlight this, and we're going to export it. And you can see here that our export types are going to be STL or, again, OBJ. These are probably going to be the two most common ones that you use. STL probably being the most common one of all. STL, I have found that it gets used everywhere. You can go to Google and search, STL relief files, and there are whole websites dedicated to where people have uploaded different STLs, and STL seems to be the very common format that people use. So it's kind of a universal thing. So we can just select that here. And again, this is pretty easy here. And now you can send this over to somebody, and this texture can be sent to somebody. They can print it. They can do whatever they want with it. They can use this. Maybe they pay for this texture and then they do something else with it. So, this is kind of something that can even kind of expand the business of what you're trying to do in terms of what types of files and what kinds of stuff that you offer. So let's look at one more example. I actually had the file open before the webinar started. This is a STL. Actually, unfortunately, I no longer have the STL. This is a 3D relief of the mountains just alongside of Salt Lake City here. So this will be the Salt Lake Valley over here, and then these are the mountains out to our east. Yeah, east. So these are the Uinta Mountains. Park City is up in here somewhere. Anyway, so I don't have the S3D STL anymore, but if I want to get that back or kind of recover that and get that back, I can use the relief to STL, and then that allows me to better scale the file, a little bit. Sometimes scaling a 3D relief can go okay, and then sometimes it can go poorly, just depending on the resolution. I honestly could probably do okay with scaling this up if I needed to, because the resolution was created initially pretty high. But if you had something that maybe was not quite as good, sometimes it's better to switch it back to an STL or a mesh, and then reconvert it back into an STL or a relief. So we're going to grab this. I'm going to rotate this just a little bit. We're going to rotate. We're going to rotate on the center axis. There we go. Okay. And we'll just move it down here in the corner. So I just wanted to rotate that so it's on its long axis here, because what we're going to do is maybe resize this. And let's see here. Let's make this a depth of 1.5. Okay. So I can scale it up this way, or what I'm going to do first is I'm going to transform this into a relief or a mesh. Now, in this example, what we're going to transition to here is now I'm going to transition into slicing a 3D object. So there's a couple examples that I want to give about slicing a 3D object, not slicing a relief, because that's different. We can actually do that. That's something you can do in EnRoute. There's no point in transitioning something from a relief to an STL or a mesh if you don't have to, if it's not leaving EnRoute. But there is also the ability to slice something in an STL. So you could actually bring it in as an STL, slice it right as an STL format, and not have to do anything else. And we'll look at an example of that as well. But I wanted to kind of start with another example. We start from a relief, convert it to a mesh, and then we slice it. So I'm going to go up to 30 on this. And mainly because what we're going to do with this file later doesn't really require much detail. And so we're going to lose a little bit of detail here, but it's not going to matter in the long run. So I'm going to hit apply. Now, again, this is kind of one of those things where this is a little bit bigger file. This actually has quite a bit more detail. The resolution on this is quite a bit higher. When I pulled this from the internet, I used and I don't remember the name of the website now, but if you Google it, you could probably find it. But it's a website where you can look at a map and then define the area that you want to convert into an STL. And it basically creates a topographical map for you based on the selected area that you have. And you can specify resolution and size and all that kind of stuff. So it's kind of a cool website. I wish I remembered what it was called. But probably a quick Google search would help us with that. But so again, this is going to be a large process. We're going to just kind of wait for this to process here. And what we're going to do is we're going to slice this into 1/4-inch pieces, I think, or maybe even smaller. And what this is going to do is it's kind of going to create a 2D effect, or it's going to create 2D parts that I can then cut that will give us like a 3D effect. And that'll be kind of a unique effect that it kind of gives us here. It'll be more of a step stair kind of effect. And I've seen a lot of these kind of maps in different places, and this is a really good way to reproduce that. So we should be getting close to being done here. There we go. I'm going to drag this out of the way. And I'm just going to put this kind of zoom out here and just kind of put it off to the side here. And we'll zoom to plate. All right, so now we have our 3D relief, or our 3D mesh, I guess. I keep mixing those up. Now you can kind of see here, it's a little bit more fuzzy and faceted than it was before. So you can definitely see that we've lost some quality, but that's okay. Again, with what we're going to do next, that's not really too important to me. I'm going to go ahead and slice this in the Z. So we're going to grab our mesh here. I can use my little shortcut to slice meshes, or if you go to Surface, Mesh Tools, Slice Meshes. And here's where I can define everything about this. Actually, before we do this, I'm going to scale this up. So I'm going to go 1.5, and I want to say proportional. Just click OK. And it's going to rescale that out for me and redraw it. And then we'll go ahead and slice it after that, because I want to do quite a bit more here. So there we go there. I'm going to use my shortcut, slice meshes, and I'm going to define my thickness. So how many do we get with 0.25? We get 6. Why don't we do, how many will 0.18 give us? Okay, that'll give us 8. Why don't we do that? So I'm going to do 8. And then there's a couple options here. I could choose to create an offset on these parts if I want to, as it slices it. I can also have it create a model, give it a label, and then put a layout for me. So I'm going to do all 3 of those. I'm going to hit apply. Now just hit close here. And what it's going to do is it's going to take this 3D object and it's going to cut it into several pieces and then create a 2-dimensional drawing for me that I can then just cut out of regular MDF, wood, whatever I want to cut it out of. And then I can stack these parts on top of each other for kind of a unique little effect. Again, this is kind of one of those processes, hurry up and wait, kind of one of those things. This is kind of one of those intense processes where, especially with this particular file that I'm using here, this is a really, really detailed file. The DPI on this is really, really high. And so this is kind of where, when you're working with smaller files, sometimes it's not big of a deal. We're going to see a file that I'm going to import in of a face later that is a much lower resolution, but kind of gives us, it's a much smaller file, so things process quite a bit quicker. But that's one of those things you have to be careful about. That topographical map website that I use is you can go really overboard on the resolution. It can cause some issues. But all right, so what we're going to do is we're going to get rid of this now because we don't need it anymore. This is our original STL. And over here on the left, you're seeing kind of a blank file. It's not actually a blank file. It is all the pieces stacked on top of each other. So let's zoom to all objects. And you can kind of see how it's created these different pieces for us. So these will get stacked on top of each other, just like that, to create a pattern. Now, if we go into the perspective view, that's where we're going to see this model really kind of pop into view here. Need to zoom out. And get a better perspective here. So now you can see what this has created. So this, out of a mountain topographical relief, we've kind of created something 2-dimensional or 3-dimensional with 2-dimensional shapes. So it kind of just splits those up into little pieces, and we have kind of a unique art style topographical map of the Salt Lake City Uinta Mountains. So this is kind of a unique kind of thing you can do with this tool. It's definitely kind of a niche thing, but there's some different and unique things that you can do with this and kind of create and kind of let your mind explore and kind of just play with it a little bit. Give you a lot of different options for different things you can do. You can also do this slicing vertically. So you don't have to just slice in the Z, you can slice on the X-axis and the Y-axis. In fact, let's go ahead and show that now. We're gonna go to a new file, and let's just import an STL file that I actually have stored here. I downloaded. What did I call it here? There we go. All right. All right, so this is just a STL file I downloaded for free off Google. So full credit to the individuals who did this. I did not make this. If we look at it from the perspective view, here's kind of what we have, right? Let's scale this down quite a bit because we don't need it to be quite so big. That's 51 inches high. I don't think we need to go that high. Let's go with 15 inches. All right. And so now I'm not even going to bother with an STL or a relief. I'm not even going to bother with it. I'm going to go straight to slicing a mesh. So I can just import an STL file, go right to slicing, and then I can slice in different ways. So now if I click on the X, it should give me some options for, let's close this here. I'm not sure why it's not showing me the lines. It was just a minute ago, but let's just do it in the Z. Let's make these 0.25. Let's make those a little bit thicker. Let's go point. There we go. So you can see here, this file is running quite a bit faster. It's a little bit smaller of a file, not quite as high a resolution. Okay. And we can zoom to the extent of all objects. And it's created all these parts. They're all labeled as to which one goes on top of which. And if we go to our perspective view, we kind of have a unique looking kind of sculpture. I'm sure you've seen sculptures that are similar to this, but that's kind of the idea there. So kind of a unique thing. And you can also, of course, slice this vertically if you want to. So we can do that as well. Let's go ahead and grab this and we'll just delete it. And delete all these parts. There we go. I'm not sure why it wasn't showing those lines before, but now you can kind of get a visual idea of where the lines are. So if I go ½ inch, it'll kind of adjust those, and you can kind of see how that changes everything. So you can kind of get a different perspective here on that face there. So again, this is kind of a pretty unique or kind of an odd example, but what you can do is, let's say you find a really nice texture and you want to use it on a wall, and you want to convert it to kind of a two-dimensional cut. You could slice items vertically and have it create these particular pieces, or all these pieces, so that you can just cut them out of some cheaper material and have them painted, or have them plastic coated, or kind of some different options there. And then those could be hung up on a wall, or they could create some kind of wall or ceiling texture. So it's kind of a different variation of the slicing that you can do for reliefs, just with the option for slicing these objects up in the 3D STL format before it even goes to relief. So this is a way to do the same thing, except for in a 3D relief format. So that's kind of the basics of slicing. Again, not too crazy or not anything like overly difficult to do, but it kind of creates some unique effects that you can kind of create and work with. There's all kinds of different examples where I've seen this used. A lot of textured wall panels could be created with this, or ceiling hanging tiles, things like that, where kind of acoustic style wall or ceiling hangings I've seen done with this, where the 3D object is complete. One of the restrictions, or one of the things that this kind of has a benefit over, let's say, a relief, is that a relief can't go under itself, right? So a relief always works off of the principle that you're running it off of a 3-axis router. And so it can never do an undercut. And so when you convert an STL to a relief, anytime that relief goes underneath itself, that kind of gets cut straight, right? And so that's kind of the limitation there. So if you were wanting to create fully circular pieces that have effects on both sides without having to necessarily compromise, and deal with the aspects of maybe cutting it in half and flipping it over, having it symmetrical and all that kind of stuff, you can get these STL files, bring them right into EnRoute, and then slice them up. And that gives you a really good way to recreate that same piece, in smaller chunks like that you can then stack and then put on top of each other, or you could even space them out from each other, things like that. So that kind of gives you another option to use those 3D objects that normally you couldn't get those undercuts on and things like that. So are there any questions on this or about slicing in general, or just an EnRoute before we call it there?
No questions at the moment in the chat. Yeah, before we close out today, you can ask Aaron anything while we have him live here. And while we wait for any potential questions to come in, I just want to mention that you may or may not be aware that this week a new version of EnRoute was released. EnRoute 23. We kind of jumped from version number 7 to 23 to keep with the overall SAI branding, but 23 is the newest version. If you're a subscriber, you can go into your cloud account and download the new version now. And if you want to upgrade, or if you're on a traditional license and want to upgrade, or if you just want to learn more about what's new in the software, you can go to our website. And we also, next month, Aaron will be doing a webinar on what's new in EnRoute 23. So that'll be an exciting one, of course.
Yeah, for sure. Next month, our webinar will be everything, kind of a brief overview of all the new features inside of EnRoute 23. So that'll be really nice and exciting. Then we're going to have a bunch of new webinars also going in depth on a lot of the new features that are in EnRoute 23. So this will be kind of a good year for some of the new features and things in EnRoute.
All right. I'm not seeing anyone typing, and we don't have any messages at the moment. So I guess you just did a great job of explaining this, Aaron. There are some unique features in EnRoute, and in EnRoute 23 specifically, there are a lot of bug fixes and new features. So it'll be exciting to go over those. But I guess for now, we'll go ahead and close it out since there are no questions. Thanks, Aaron, for going through that with us, and thanks for everyone for being here today. Just wanted to remind you again about the webinar next month about EnRoute 23. That'll be on February 21st. We hope to see you there, and we'll have a link to sign up for that in the follow-up email that you'll receive today. Make sure to subscribe to our newsletter so you won't miss out on any other webinars or announcements. You can sign up for that on our website. Thanks again for being here. We hope you learned something, and we'll see you next time.
Have a good one.